Hi, everybody. This is the walkthrough video for Thursday, April 10th. It is try 3, week 7. And to make sure that we have enough time to do what we need to do, you're actually going to skip your do now for today. You can write same for this one. We're going to think together about how different lizard species came to be on different nearby islands. This is day 2 of our 2.5 day assignment. Today's assignment, if you are absent and you don't have a paper copy, you can do what I'm going to suggest you do here on this sweet lizard workspace. But you are going to need the part of the assignment, as you'll see, that kind of begins down here. This is where we're going to start our work together today. So remember the story about how there's recent common ancestry and that's divergent evolution, and then you can have no recent common ancestor. I tried to fix this particular situation because they do have a common ancestor. We're all commonly related, but flight is not closely evolutionary related, right? So what we're going to try to figure out together today is all of those islands in the Caribbean. I should probably grab that slide again. Listen, all of these islands in the Caribbean have all of these different creatures, right? They all have crown giant anoles, those big green lizards. You saw some of them are bluish, some of them are green. They all have those twig anoles who have little itty bitty legs that let them grip. They all have grass bush anoles. And the question is, where did they come from? Are those ecomorphs just convergent evolution? They a lizard showed up on an island, one lizard species over time gave rise to lots of them. We call that adaptive radiation. Or was it a story about these saber-toothed animals? So these are two skulls. They belong to extinct animals, and both of them have saber teeth. Those are long, ferocious canines with serrated edges like a steak knife. And I would have thought that these two animals are pretty closely related. They show up at about the same time and in the fossil record, I think. But it turns out that they are actually very, very different. So the one on the left is more closely related to kangaroos and koala, and the one on the right is more closely related to us than they are to this animal. So that's an example of convergent evolution, right? This idea that they are all together. So it's either this, which is one shows up and they make these types and then these kind of fly away, or is it the other one? So that's what we're going to think about today. Is it adaptive radiation or is it convergent evolution? So here's figure 2. You're going to need a big, colorful version of figure 2, I think, to answer 4, 5, and 6. I just gave you some ideas about adaptive radiation, this idea that there was an ancestral lizard. We don't know how far along, how far back. And the question we're really trying to figure out isn't just about adaptive radiation. I'll probably change this language for next year. It's about migration versus convergent evolution, right? This idea that what ends up happening is that over time you get range changes. And so maybe that's what's happening. Anyway, pause the video and answer 4, 5, and 6. If 6 is hard, I'll give you a hint in a moment. Okay, cool. So today we're going to think about why similar ecomorphs can be found on each of the different Caribbean islands. And there are kind of 2 examples, and I'm going to use this picture of migration instead. So one of the hypotheses is that each ecomorph evolved once and migrated across the narrow channels in between islands and spread to the other islands. Or maybe sea levels have changed and some of the islands were connected when they evolved, and then they became separated. If that's true, you would expect to find that species belonging to each ecomorph would be more closely related to each other than to species belonging to other ecomorphs, right? Like maybe the hurricanes blew the lizards around. Hypothesis 2 is that each of those ecomorphs evolved repeatedly and independently on each of those islands, and they're examples of convergent evolution. So again, we know it's adaptive radiation. I'm going to take this picture to talk about migration. Maybe you're just ending up with species changing their ranges and changing in between the islands, or maybe it is convergent evolution. So the next order of business, you'll see here, you're going to need this text sequence file. You're going to need this tree making website. If you are in class, you can pick up a printed out copy of the tree, or you're going to copy and paste the tree from phylogeny.fr, which I'll show you how to make in a moment, into your copy of a lizard workspace twice. And then you're going to color code like I'm going to show you in a moment. So here are the instructions that are on your worksheet, excuse me, for this part. So you're going to download the DNA sequence text file. And when you click on this page, you are going to see just a lot of text, and you're going to select all. Whoops. You're going to select all. You're going to copy it, Control C to do that. Now, the next thing you're going to do is open up this website. By the way, you should know what thing are you picking up. This file includes the DNA sequences of all 16 lizards that are in the photographs. That sequence is a stretch of mitochondrial genes that include an NADH dehydrogenase unit and some tRNA genes. Those genes are conserved enough that everybody's got them and they don't vary a ton in sequence, but you can also figure out individual species because of the mutations that they have in that. It's like a sweet spot. So genes like these are used for DNA fingerprinting of species. So in addition to the anoles, you're also going to see this sequence for a lizard whose first name is not Anolis. So all of these sequences say Anolis, but this one doesn't. It is a less related lizard, and we're going to use that, like the slides say and your assignment says, as an outgroup to root the tree to help make it so that the tree knows which thing is the much least commonly related. So you're going to open the website. It has Aladdin's lamp on it with a tree coming out from it. And you're going to follow these instructions. In this particular case, you're going to open the sequence file. You're going to copy all and paste it, click submit. You'll end up with 2 copies of the phylogenetic tree, and you're going to post those into the lizard workspace. Show you what that looks like. If you are doing this assignment digitally, here are the lizard cards. You made your own copy when you sorted them around. Here's the place where you're going to do the trees. So it says, if you're not in class, take a screenshot of your tree and paste it twice side by side. You might need to shrink the screenshots to get the tree side by side. That's fine. And then you're going to use the line tool, which is this one, or the scribble tool, which is what I use in the example I'm going to show you in a minute, to do that color coding that we're going to look at together. Let me get back to that instruction page. Cool. So what you're going to do here, I should probably just put this again here separately. A second. Making some good plans. Here we go. So what you're going to do is color the phylogenetic trees to get a visual picture of how the species evolved. So for one of the trees, you're going to color code them by island of origin. And if both branches are the same color and they meet in what we call a node, you're going to color the root branch and keep going. And if they don't match up again, you're just going to leave the next ones blank. And then make sure you include a legend. I'll tell you how to do that in a minute. And then you're going to color each branch similarly according to the ecomorph. So you've got 2 trees going. Here's an example. So here are the species names, here are the islands, and here are the ecomorphs. You can also find that at the very end of your assignment. It's on the last page if it's hard to see on the screen. And so what you're going to do is say, okay, here, for example, are 2 lizards. They're both from Cuba. And I'm going to look up here in the color coding by island, and I'm going to find them, and I'm going to color Cuba red in this experience. Now, don't box them like I just did, because you're going to need to figure out this and this later on. So I colored both those branches red. I made a list, or like colored in Cuba over Cuba with a marker. I like put a star next to it or a line showing that color. And then if they're connected, I'm going to keep going backwards, which is what I've done here. So if both these are red, I'm going to color the back branch red as well. So today you're going to continue through the assignment. You'll see that there are some questions from analysis of 1, 2, and 3. You do not need to use complete sentences. General patterns are whether the colors are together or whether they are pretty separated in the pictures, and the pictures will give you that clear answer. And then for the questions on page 5, you do need to use complete sentences. So by the time you are done with this part of class, you should be done with question 4, question 5, and question 6. So we'll do question 7 tomorrow, which will be great for us. Last but not least, I've got a cool down. This is a word that we used repeatedly in this video. You can scroll back to find it. It's when 2 species have similar morphology, even though they aren't closely related. They don't share a recent common ancestor. All right, that's it for me. Hope you're taking care out there. See you soon.